Hello, here we are with trig equations and identities, page 3. First, we're going to talk about the reading. You can always find a decimal or numerical solution of trigonometric equations using a calculator. If the solutions are multiples of pi over 6 and pi over 4, which are 30 degrees and 45 degrees, you can find an exact solution using algebra. This is called an analytical solution. We use the periodicity of the trig functions to find all the solutions in the specified domain. Remember that sine x and cosine x have a period of 2 pi, and tangent x has a period of pi. Consider sine x equals 1. We know that one solution is pi over 2, which is 90 degrees. What are 3 other solutions? Okay, and I haven't specified a domain here, so you can give me any solutions you want to. So pi over 2 is 90 degrees. We know that every 360 degrees you're going to get another solution. So instead of pi over 2, we could have pi over 2 plus 2 pi, which is the same thing as 5 halves pi. That's 2 pi plus pi over 2. And then we could add 2 pi to that. 2 pi is the same as 4 over 2 pi. 4 over 2 pi plus 5 over 2 pi is 9 over 2 pi. And then we could have one more. We could actually subtract 2 pi from pi over 2 also. That would be 1 half pi minus 4 halves pi. That would be negative 3 halves pi. Okay, so those are 3 other solutions to sine x equals 1, right? All of those angles, if you put them into the calculator and do sine on it, you will get 1. Write the general solution using the integer k. So we could say that the most obvious solution is pi over 2, but every 2 pi after that, you could write k2 pi or 2 pi k. You can get other solutions, and k could be negative too. So k could be positive or negative integer or 0. Okay, here we are on number 1. Solve for x on the domain between 0 and 4 pi. Okay, so we're going to try to solve these analytically. Eventually, the answers are going to be multiples of 30 degrees or 45 degrees because that's the only way we could do it without the calculator. Okay, so remember, our objective with algebra is always to isolate the x. So the first thing we want to do is start from the outside, which is negative minus 1. We're going to add 1 to both sides. That'll give us 2 cosine x equals 1. Now we want to get cosine x by itself, so we divide both sides by 2. So we get cosine x equals 1 half. Now we just need to use our knowledge of the unit circle. What's the most obvious angle which gives us a cosine of 1 half? Cosine of 1 half means the x coordinate is 1 half. So that, and then the y coordinate, we know that the y coordinate that goes with 1 half would be square root of 3 over 2. This looks like 60 degrees, right? So x equals pi over 3, which is 60 degrees in radians, would be one of the solutions. So that gives us 1 half, right? And then we know that we need to make sure that we don't go smaller than 0 or bigger than 4 pi because those are the limits to the domain. What else could we, what other angles have a cosine of 1 half? Well, remember that there's a reflected triangle down here which also has a cosine of 1 half. So that would be negative pi over 3. Of course, negative pi over 3 is too small, right? Because it's smaller than the 0 here. So let's look for bigger numbers, not smaller than pi over 3. What about if we had this angle here, which is negative pi over 3? What if we add 2 pi to that? So that would be adding 6/3 pi to that. 6/3 pi minus 1/3 pi is 5/3 pi, so that would be 5/3 pi, right? So So that's another possible solution. That also gives us a cosine of 1/2. And let's see, then we would want to add 2 pi to pi over 3. That would be 6/3 pi plus 1/3 pi, which is 7/3 pi. Okay, that also gives us 1/2. And then we're going to add another 2 pi to 5/3 pi. So 5/3 pi plus 6/3 pi is 11/3 pi. And 11/3 pi. 11/3 pi is about 3 point something. Okay, so we're getting close to 4, aren't we? Let's try adding one more 2 pi to this one. Adding 2 pi to 7/3 pi, that would be 6/3 pi plus 7/3 pi, that would be 13/3 pi. 13/3 pi would be slightly more than 4 pi, so we don't want to go any further than that. I am going to do this. I'm going to put my limits in black. So 0 is a limit. Okay, so basically I have 4 solutions, which are pi over 3, 5/3 pi, 7/3 pi, and 11/3 pi. Those all give me a cosine of 1/2, which solves this equation. Moving on to tan x equals 1. Remember that our domain is 0 to 4 pi, okay? So this one's pretty straightforward. I don't even need to do any algebra. I just need to start thinking, okay, what is the most basic angle which gives me a tangent value of 1? And that would be a triangle that is square root of 2 over 2, square root of 2 over 2, okay? And the opposite over adjacent would give me 1 in this case. This is a 45-degree angle or a pi over 4 angle, okay? So in that case, I'm going to have a table where I have x and tangent of x. And my first most obvious angle is going to be 45 degrees or pi over 4. And my smallest, or the limit to my domain is going to be 0 and 4 pi. Okay. Now what other angle has a tangent of 1? The other angle that has a tangent of 1 between 0 and 360 would be this angle here, right? This has a opposite and adjacent that are negative. So it'd be negative square root of 3 over 2, negative square root of 2 over 2, and negative square root of 2 over 2. When you divide those two, you get a tangent of positive 1 because two negative numbers will give you a positive. So we know that that angle here is going to be 180 degrees plus 45, which is 1 pi plus 4 pi over 4, which is 5/4 pi. So that angle is 5/4 pi. Now, when we get our additional angles, we know that we can add 2 pi to each one of these angles. So we're going to add 2 pi to 4 pi. That'll give us 8/4 pi plus 4/4 pi is going to give us 8/4 pi plus 1/4 pi is 9/4 pi. Okay, and then we're going to add 2 pi to the orange angle. So that would be 8/4 pi plus 5/4 pi, which would be 13/4 pi. And 13/4 pi, let's see, that's equal to 3 point something. Okay, so we haven't gone past 4 pi yet, but I imagine that if we add 2 pi more to this, which would be 8/4 pi plus 9/4 pi, that would be 17/4 pi. That would be slightly above 4 because 17 divided by 4 is 4 point something. Okay, so we don't need to add any more because we know that the limit is the upper limit is 4 pi. So we've already found all the solutions between 0 and 4 pi. All of these, if we put it into the tangent function, give us 1, like the original function asks us to figure out. Okay, here we are on 2a. This is a similar problem. We've got a little bit of algebra to do here to isolate the x. So first thing we're going to do is we're going to add square root of 3 to both sides. Then we're going to get 2 sine x equals square root of 3. Then we're going to divide both sides by 2. And we'll have sine of x equals square root of 3 over 2. And we know what angle gives us the sine of square root of 3 over 2. It looks like this. It's got square root of 3 over 2 on the opposite, and it's got 1/2 on the adjacent. And this is a 60-degree angle, also known as pi over 3. Okay? And this is, we're looking for another triangle, maybe, that has the same sine, which is square root of 3 over 2. It's right here. This one here. This one has a cosine of negative 1/2, but the sine value is square root of 3 over 2 also, right? And this angle here is pi over 2, which is 90 degrees, plus another pi over 6, right? Because it would be like 90 degrees plus 30 degrees. So that would be pi over 6 plus 1/2 pi, which is equal to pi over 6 plus 3/6 pi, which is 4/6 pi, which is 2/3 pi. Okay, so now you know why I asked you to be able to figure out, sines and cosine values from 0 to 360, right? So what did I say again? It was 2/3 pi, right? So 2/3 pi is the orange one. And the red one was pi over 3. And oh, look at that though. We can find any x value between negative 2 pi and 2 pi. So now this time I think these two values are going to be kind of in the middle, and we can subtract 2 pi also. So both of these give us a sine value of square root of 3 over 2. Okay? And our minimum domain value is negative 2 pi. And our maximum domain value is positive 2 pi. Okay? So is there any values that are bigger than pi over 3? If we add 2 pi to this, are we going to get a number that's below 2 pi? No, we're not. So we cannot add 2 pi to pi over 3. We cannot add 2 pi to 2/3 pi. We're going to get numbers that are bigger than 2 pi. So we know that those are the biggest possible. So let's subtract 2 pi from pi over 3. So 1/3 pi minus 6/3 pi, remember 6/3 pi is 2 pi, 1/3 pi minus 6/3 pi is negative 5/3 pi. And that is not smaller than negative 2 pi, negative 6/3 pi. That's the same thing as 2 pi, right? And then we're going to subtract 2 pi from that one. 2/3 pi minus 6/3 pi is negative 4/3 pi. Okay, and so these all have sine values of positive square root of 3 over 2. So we found the 4 possible answers for this one. Here we are on part C. Once again, we're going to have a domain, which is negative 2 pi to 2 pi. And this is pretty straightforward. Tangent of x equals negative 1, no algebra necessary. We know that tangent of negative 1, that would be like a 45-degree triangle. The 45-degree triangle would be maybe pointing in that direction. This has a positive square root of 2 over 2 sine value, a negative square root of 2 over 2 cosine value, and when you divide the two, you get negative 1. So I always know that whenever you have a tangent of 1, we're always looking at a 45-degree triangle which has legs that are the same length, right? So this is one of the solutions. This is 90 degrees plus 45 degrees, which is pi over 2 plus pi over 4, which is equal to 3/4 pi. So one of the angles is 3/4 pi. The other triangle would be down here, because this has a negative sine value and a positive cosine value. When you divide these, you also get negative 1. So this would be, let's see, it would be 3/4 pi plus 1 pi. So that would be 7/4 pi. Okay, and so basically we're going to make another table. Oh, I forgot to put x here. So we're going to have another table just like that one, except this one's going to be x and tan x. And our limits for our domain are going to be negative 2 pi minimum, positive 2 pi maximum. And we know that somewhere in the middle, we're going to have 3/4 pi as our red angle, and our orange angle would be 7/4 pi. So, and if we do add 2 pi to 3/4 pi, we know that we're going to get an angle that is bigger than the maximum limit of 2 pi, so we don't even try to do that. But we can try to subtract 2 pi from 3/4 pi. Now remember, 2 pi is 8/4 pi, so 3/4 pi minus 8/4 pi is negative 5/4 pi, so that would be 1. Negative 5/4 pi, right? And we could also subtract from the orange angle 2 pi, so 7/4 pi minus 8/4 pi, that would be negative 1/4 pi. Now if we try to subtract from the orange angle again, negative 1/4 pi minus 2 pi, we would clearly go past our limit here, so we can't subtract 2 pi anymore. So we've just found all 4 possible answers. All 4 of these answers give us a tangent value of negative 1, so that's what we wanted, right? And we found all of them in between negative 2 pi and pi. On to number 3. So now we're looking at a domain between 0 and 2 pi. What are the possible values of 2x, x plus pi over 2, and 2 times x minus pi over 4? Okay, now what we're doing right now is we're just figuring out limits to the domain. So the original limits to the domain are 0 and 2 pi. Now if we multiply the x times 2, the middle expression becomes 2x, right? And then everything else gets multiplied by 2 also. So the maximum limit becomes 4 pi, and the minimum limit, 0 times 2, continues to be 0. Okay? What about if we add pi over 2 to x? What happens to the limits then? So then our inside expression becomes x plus pi over 2, and the left and the right limits become 0 plus pi over 2, which is just pi over 2, and the right limit 2 pi becomes 2 pi plus pi over 2, which is 4/2 pi plus 1/2 pi equals 5/2 pi. And last of all, we have the most complex one, which is first what they're going to do, and I'll do this in steps. So in PEMDAS, we're supposed to subtract the pi over 4 first. So if we subtract pi over 4 from the inside, the left limit becomes negative pi over 4. The right limit becomes 2 pi minus pi over 4, which would be 8/4 pi minus 1/4 pi, which is 7/4 pi. Okay, and then we multiply each one of these elements by 2. So when we multiply the middle element by 2, we end up with the same thing as what's written here. And then the left and the right limits become negative 2/4 pi, which is the same thing as negative pi over 2. And the right limit, 7/4 pi, becomes 14/4 pi, or we could also say 7/2 pi. Okay? Number 4, if x is between negative pi and pi, what are the possible values of 3x, x minus pi over 2, and negative 2x? Again, we're changing the domain. So if we multiply the middle expression by 3, we get 3x like here. Then we multiply both the left and the right limits by 3 also. So the left limit becomes negative 3 pi. The right limits becomes positive 3 pi. And so basically, yeah, so that's our answer. Okay, and then our next one, we're going to take the middle expression. We're going to subtract we're going to subtract pi over 2, and we'll go get that. And then we do the same thing to the left and right. So minus pi over 2, and positive pi minus pi over 2. And we can simplify these because minus pi over 2 is the same thing as negative 3/2 pi. And the middle expression continues to be x minus pi over 2. And the right expression, pi minus pi over 2, becomes pi over 2. And last of all, if we multiply the middle expression by negative 2, we get negative 2x, like there. And then we multiply the left expression by negative 2, and we'll get negative 2 times minus pi, that would be positive 2 pi. And the right expression, pi times negative 2, would be negative 2 pi. And there's one trick. If you multiply everything by negative 2, doesn't that invert the inequalities? So actually what we get is this, okay? And if you're more comfortable with it, you can actually reverse the direction of everything, but this is fine the way it is. 5 now. Solve exactly for the domain 0 to 3 pi. So first one's pretty straightforward. All we're going to do is we're going to figure out what basic triangle gives us a cosine of 1/2. Cosine of 1/2 means the adjacent of 1/2, so that would be one of these tall triangles like this. So if the adjacent is 1/2, the opposite is square root of 3 over 2. So this would be a 60-degree triangle, also known as pi over 3, right? Where's another triangle that also has a cosine of 1/2? That would be the triangle that's reflected down, like that. So that would be like negative pi over 3, or we could also call it 2 pi minus pi over 3, which would be 6/3 pi minus 1/3 pi, which is 5/3 pi. Okay, so those would be the two possibilities. The first possibility is pi over 3. The second possibility is 5/3 pi. And let's draw the little table. So we're looking for x and cosine x values. So for both of these, the cosine x value is 1/2, right? And our domain is between 0 and 3 pi. So let's start adding 2 pi to all of our solutions. If we add 2 pi to pi over 3, that'll give us 6/3 pi plus 1/3 pi is 7/3 pi. If we added 2 pi again to that, 6/3 pi plus 7/3 pi, that would give us 13/3 pi. 13/3 pi is a little bit more than 4, so that's past 3 pi, so we wouldn't add again. Let's do the orange one. 5/3 pi plus 6/3 pi would be 11/3 pi. 11/3 pi. That looks like a 4. 11/3 pi. And if we added 11/3 pi is slightly over 3 already. So actually 11/3 pi is also not possible because that goes past our domain of 3 pi. Let's do a subtraction of 5/3 pi. So we're going to subtract 2 pi from that. So it would be 5/3 pi minus 6/3 pi. Remember, 6/3 pi is the same as 2 pi. 5/3 pi minus 6/3 pi gives us negative 1/3 pi. So negative pi over 3. And pi over 3 minus 2 pi would be, now we're already getting into negative numbers. So that goes below the black 0. So we don't want this, and we don't want this. So we're done. There's only 3 solutions. There's 3 solutions which give us a cosine value of 1/2 between 0 and 3 pi. Last one, okay? This one has like a transformation in between, so we're going to do a little bit differently, okay? First of all, let's do what we did above, and we're going to figure out what the the limits of the domain. So we know that x is between 0 and 3 pi, right? If x is between 0 and 3 pi, what about x plus pi over 3? What's the domain of this? The domain of this would be 3 pi plus pi over 3, so that would be 9/3 pi plus 1/3 pi is 10/3 pi. I should do this in black because we do our domain in black. What was it again? It would be 9/3 pi plus 1/3 pi, which is 10 pi over 3. And the 0 becomes pi over 3. Okay, so that's our domain for the x plus pi over 3 expression. Okay, so we're going to make a new table. And this table is going to have 3 columns instead. It's going to have the x column, it's going to have the x plus pi over 3 column, and it's going to have the cosine of x plus pi over 3 column. Okay, so we're looking to make all these 1/2. So like we're finding everything that makes the cosine of x plus pi over 3 1/2. What does one of those triangles look like? So what is x plus pi over 3 that would make the cosine 1/2? Well, cosine of 1/2, that means the adjacent is 1/2. So it could be this triangle here, 1/2 on the adjacent and square root of 3 over 2 on the opposite. This is a 60-degree triangle, also known as pi over 3. So that is one of the possible solutions, pi over 3. And let's write down our domain. So the domain for x is 0 to 3 pi. The domain for x plus pi over 3 is pi over 3, including pi over 3, right? Includes it. And the maximum is 10/3 pi. Okay, so pi over 3, which we just calculated pi over 3 as a possibility, pi over 3 is fine, it's within the domain. If we have pi over 3 in the x plus pi over 3 column, how do we get x? Well, if x plus pi over 3 is pi over 3, that means x is 0, right? I just kind of guessed that. But I could do it with algebra. If I have x plus pi over 3 is pi over 3, I could subtract pi over 3 from this value, and that would give me the original x value. So that's what I did. Pi over 3 minus pi over 3. I did the opposite of this, and then I get that the original x value is 0. Okay? All right, and I know there's no other possibilities below that because pi over 3 here is already at the bottom of the domain. Now let's look to see if there's any other basic triangles that have a cosine of 1/2. And I know that this reflection down here does. Remember this one? We already looked at this one. It's 5/3 pi, right? So we'll put 5/3 pi here too, because that's also an angle that gives us a cosine of 1/2. Okay, and if the middle angle is 5/3 pi, if pi x plus pi over 3 is 5/3 pi, that must mean that the original angle was 4/3 pi, because 4/3 pi plus 1/3 pi is 5/3 pi. So here we are. Are we there yet? No, we got a lot of space here. So let's start adding. Let's start adding 2 pi. So we'll add 2 pi to that angle. So this will become 2 pi. This will become 2 pi plus pi over 3, which is 6/3 pi plus 1/3 pi, which is 7/3 pi. So that's another angle which has a cosine of 1/2. And then let's add something to the orange angle. So the 4/3 pi becomes plus 6/3 pi would be 10/3 pi, which is a slightly bigger than 3. So we're already over this limit. So we are going to get rid of that actually. We're already done. Okay, so, and we were looking for the x values, not the x plus pi over 3 values, so that the 3 values are 0, 4/3 pi, and 2 pi.